in the chat box. You know everything that how to interact me in the chat box. Write a role in the chat box so I can trace you. So for the lecture purpose, I am muting all for the lecture purpose. Okay.
Okay.
Okay. So everyone is muted right now. Probably there is some power issue. He has been said there is some power issue, um, but no problem. We will start. We'll start because we have also the class uh, in the video lecture they will have. So I think it will help them. But still, the live class is important. So basically, in the last two class, we have discussed about the diode configuration, about how the diode have been built, the PN junction. Then we discussed three things: no bias condition, then the forward bias condition, and the reverse bias condition. We told that when the applied voltage is 0, there will be no current in the diode. When the applied voltage will be greater than 0, that means positive voltage, at that time it will have the current will flow. Basically the current will flow. And when we will apply the negative voltage, it will be there will be no current flowing. So that is reverse biased condition. So today we will see that diode mathematics. We'll see the diode mathematics. Okay. Different types of diode mathematics in circuits. So no more explanation will be given from today, because we have already know. So we have already know that how diode works. So there are two difference. One is ideal diode, one is practical diode. The practical diode is basically built with silicon, but the ideal diode today we'll discuss. You see that this is the diode symbol. This is the diode symbol. Yeah, students, if you have any question, you can make the question in the chat box, and also drop your role and batch in the chat box. Drop your role and batch in the chat box, and also your question. Okay. So the students are joining. No problem. Students are joining. So this is the ideal diode. You see that this is the diode symbol. This triangular structure and a vertical line. This is the diode symbol. In the last class we also saw. This is the diode symbol. So this is P and this is N. So we all know that the P and N junction together builds a diode. So this is the diode symbol. This is the diode symbol. This is the P and this is the N. Okay. So we all know that. So when the voltage across diode, is 0, there will be no current. The current will be 0. Okay. When the voltage across diode will be 0, the current will be also 0. You see that this graph, you see that this is the 0 point. When it crosses the 0 in ideal diode, basically we are discussing about ideal diode. When it crosses the 0, it will be in forward bias. The huge amount of current will flow. But when the voltage is less than 0, it will be in the reverse bias. Basically, the next condition we are talking about, you see that in the forward bias, that means when the voltage applied across the diode is greater than zero, the positive voltage. Positive voltage means forward bias, negative voltage means reverse bias. So when it is forward bias or positive voltage, you see that the P and N, the P will be connected with the positive terminal and the N will be connected in the negative terminal. In this configuration, this is known as positive bias configuration. At that time, the ideal diode will just act as a shorted line. There will be shorted line. At that time, there will be no voltage drop, but the current will flow. It's just like a shorted two terminal. It will be shorted. Okay. So in the forward bias, again I'm saying in the forward bias, the P will be connected with the positive terminal and the N will be connected with the negative terminal. And when the voltage will be positive, it will be like shorted. You see that the shorted line, and there will be no voltage drop because it's just a shorted line. In the electrical circuit, we know that in a shorted line there will be very less amount of resistance. So when there will be very less amount or negligible amount of resistance, so there will be no voltage drop. There will be no voltage drop. That's why the Vd equals to 0. Okay. And in the reverse bias configuration, that means now we will apply the negative voltage. The negative voltage, that means the P will be, that means P will be in the negative terminal and N will be in the positive terminal. That means we are applying the negative voltage in the PN junction or PN junction diode. Okay. When the P will be in the negative terminal and the N will be the positive terminal, it is known as reversed bias condition. And we all know that in the reverse bias condition, there is no current flowing. In the reverse biased condition, there will be no current flowing. So you see that in the right side, the terminal are open. The two terminal are open. That means it becomes open circuit. It becomes open circuit, and we all know that in the open circuit, the current will not flow until it becomes shorted or until it becomes the closed circuit. The current will not flow. In the open circuit, it will not flow the current. So that's why you see that the ID equals to 0 ampere. We already know when the negative voltage or reverse bias condition comes in the PN junction diode, there is no current flowing throughout the diode. That means the current flow throughout the diode is 0. Okay. So that was the practical diode. That was the ideal diode. Now we will discuss the practical diode. Okay. So what is the difference between the practical diode and the ideal diode? So the difference is only one place, that is barrier potential. That is barrier potential. And we all know that for silicon diode, the barrier potential is 0.7 volt. Please remember this. For silicon diode, the barrier potential is 0.7 volt. And for germanium, it is 0.3 volt. But as the silicon is the most used, that's why we will discuss about the silicon. Okay. So you see that the silicon diode, the barrier potential is 0.7 volt. So you can also see the change, in the graph also. In this graph, you can see the change in this graph. Now it is not working at 0 volt. Now it is not working at 0 volt because now when the voltage we will apply, it will not work until 0.7 volt. When the voltage, the positive voltage will become 0.7 volt, at that time it will become forward biased. You see that FB is basically forward bias, not Facebook. FB is forward bias, RB is reverse biased. So when this the applied voltage VD becomes zero point 0.7 volt. At that time, the diode becomes forward biased, so it will flow the current. It will, it will allow to flow the current. But as soon as, suppose the current is the voltage is 0.3 volt, it will not open, it will remain, it will not allow the current, it will not flow the current, it will remain as open circuit. Similarly, for reverse voltage, it will not flow the current. So you see that in the condition when the VD equals to 0, there will be no current. Remember, always remember, when the VD, the voltage across diode is 0, there will be no current flowing in the diode. Okay. So now you can see the forward bias and reverse bias condition. In the forward bias, basically the voltage will be greater than or equal 0.7 volt, will be greater than or equal 0.7 volt when it will be there, and the P will be positive connected and the N will be negative connected. Always remember, this triangular is P and this vertical line is N. Okay, so when the positive terminal is P and the negative terminal with N, it is forward biased, it is forward biased. So when this zero point 0.7 volt will be applied here, it will be just like shorted and there will be a voltage drop, there will be a voltage drop 0.7 volt, which will act as just like a battery source, just like a battery source of 0.7 volt, and the current will flow. Again, I am saying, for the practical diode of silicon, when it is forward biased, it will act like a zero point 0.7, it will act like a zero point 0.7 volt battery source, and the current will flow, the current will flow. Okay, but the reverse bias condition, that means when the voltage is less than 0, but that means negative voltage, we are talking about negative voltage. Please students, if you do not give your role, please give your role in the chat box, give your role in the chat box, and also your feedback, your question in the chat box. So in the reverse bias condition, when the P and the N, P with the negative and N in the positive, that is reverse bias condition. And you can see in that time, the reverse bias condition, there will be no current flow, and that the two terminal will be open circuit and there will be no current flow. That's why the ID equals to 0 ampere. Okay, so this is the configuration. Always remember, the forward biased current will flow, the reverse bias the current will not flow. Okay, that is only one thing. And how to see forward bias and negative and reverse bias? The forward bias is P with positive, N with negative, and reverse bias P with negative, N with positive. Okay, now we'll go to the some example configuration. This, so first one, suppose you can see this circuit, you can see a circuit here, yes, you can see a circuit here. So here you can see a voltage source, that is 8 volt, a diode, and a resistance is connected in series, everything is given. The voltage source is 8 volt, the resistance is 2.2 kilovolt, 2.2 kilovolt, sorry, not 2.2 kilovolt, it's 2.2 kilo ohm, and there is a silicon diode is given. So for this configuration, we need to find out the value of VD. VD is the diode voltage. You see that VD is the diode voltage. VR is the voltage across this resistance, and ID is this current, series current in this circuit, the series current in this circuit. So At first see, at first see in this configuration, is this diode is positive and forward biased or reverse biased. I'm muting, unmuting all. I'm unmuting all, and I want the answer from other students, all the students. The students, is this diode forward biased or negative
This is
biased?
this is forward, sir.
This is
Forward bias.
forward.
Forward
Everyone,
bias.
Bias.
everyone understood?
Yes,
Yes.
sir.
Sir.
Why?
Forward bias, sir.
So, sir, the P is a
Because of
positive, sir.
Yes, you see that this P configuration, the triangular is P, the vertical line is N. Okay, so
Is
this
N, yes.
P is connected with the positive and N
And N is
with the
connected to the
negative.
negative.
Sir, how we can understand? You see that? Yeah, Mustafa, I will answer your question. Just give me 1 minute. You see that this is the voltage source, 8 volt. So the current will start to flow from here. Okay, the
Yes.
current will start to flow from here. Always remember, when the current enters any kind of load in that side becomes positive.
to pass.
You know, from this circuit.
Yes, sir, we know.
Yes, sir.
Yes, that terminal becomes positive, and the current leaving that load, that
Yes.
becomes negative. This is
Negative.
universal rule. I think
Yes,
that
sir,
you
we know
have
it.
studied this in the electrical
Second.
circuits.
Second semester, sir.
Yes,
So
sir.
that's why this AP is connected with P and N is connected in the negative or minus. That's why we can tell that this diode is in forward biased condition. Okay, Mustafa, tell your question. Mustafa Al Nafis, tell your question.
No, sir. No, sir.
There is no question.
Yes, sir.
No, sir. I understand that it is
Okay.
forward
Okay.
biased.
Okay. Excellent. Please try to listen my words. I will repeat my words. Okay, no problem. I will try to repeat my words every time, so you will just be patient and try to listen my words. I'm going very slowly. I'm talking very slowly, so that's why you can understand
Yes, sir.
properly. So from here, yeah, I'm muting all. I'm
Yes,
muting
sir.
all because it will give echo. So from this configuration, we already understood that, sir, this is forward biased. This is forward biased condition. It is in. So we all know that in forward bias condition, as it is a silicon diode, the silicon diode, the barrier potential is 0.7 volt. So it will not work. This circuit will be not worked until this voltage becomes 0.7. So we have already 8 volt. So this 8 volt will be distributed here and here. Okay, we all know that. So the input voltage is equals to the summation of the drop voltage of different loads. So as this is a forward biased, so the voltage across the silicon will be 0.7 volt. That is the barrier potential. That's why it is written the diode is in forward biased condition. So the diode voltage VD equals to 0.7 volt as it is silicon. That's why the diode voltage is 0.7 volt. If it is germanium, then it will be 0.3 volt. Okay, so from this circuit we already understood, we already determined what is VD. Next is find out VR. Next you need to find out VR. You see that if we apply a KVL here, if we apply a KVL in this circuit, at that time we get this equation. You see that applying KVL, as we all know that how to apply the KVL, we take the first sign for all or the second sign or for all. Suppose this is the first sign. Okay, for this is the first sign. For this is the first sign for this. So applying KVL, it will take plus E. We are taking the second sign plus E. Okay, plus E. We are taking the second sign plus E. Then we are taking the second sign, plus minus VD. It is not plus, it is minus, because the first sign is plus, the second sign is minus. We are taking the second sign for everyone. The second sign is plus E minus VD and the minus VR. The minus VR equals to 0. That is the KVL. We take all the second sign and we get the equation equals to 0. So from here we know that we need to find out the VR. We need to find out the VR. So to find out VR, we take VR one side and everything on the other side. Now we need to find out the VR. We know that, sir, the value of E is 8 volt, that is given in the circuit, and the value of VD is 0.7 volt. So 8 minus 0.7, it becomes 7.3. So the voltage across the resistance, it becomes 7.3. Very easy. It's a very easy thing. So the next thing we need to find out ID, the current ID. You see that this current ID is the series current in this circuit. Series current. So basically the ID or the current in the will also go in the resistance. So if I tell the resistance current is IR, at that time ID will be IR, because this is the series current. We all know that the current in the series circuit is same. So to find out ID, ID equals to IR, and we all know that the Ohm's law, the VR by R, the voltage divided by the resistance. Okay, so the VR by R, we all know that the VR value is 7.3 volt and the R value given in the circuit, that is 2.2 kilo ohm. If we divide, it will be 3.32 milliampere. So that was the solve in this series diode configuration. Okay, now if we repeat this example for reverse bias configuration, suppose this is the reverse bias configuration. Check my students, this is reverse bias configuration. How? You see that when the current will enter here, now the N will be positive, the P will be negative. So the diode is in the reverse condition, in the reverse bias condition. The diode, hope you understand. I discussed very openly in the very first slide that when the N is positive, the P is negative, it will be in the reverse bias configuration. So when it is reverse bias configuration, we all know that this will be open circuit. There will be no current flow. When there will be no current flow here, the current will not flow in the resistance also. The current will not flow in the resistance also, because the open circuit is here. It is open circuit, so the whole circuit becomes open. So there will be no current flow. That's why the value of ID will be 0. When the ID equals to 0, as it is a series, the IR is also 0. The current across resistance is also 0. When the current across resistance is 0, we all know that there is no current, there will be no voltage drop. So the VR is also 0. The voltage across resistance is also 0. Just for the reverse condition. So that's what is VD. You see that this is the series circuit. So the all voltage, the VD will be E minus VR. The VR is 0, so the VD equals to E. Basically the whole voltage will be applied in the VD. The whole voltage will be applied in the VD, so the VD will be equals to 8 volt. We all know that when it becomes open circuit, the whole voltage is applied on the open circuit terminal. Okay, that's how the reverse bias condition works. So I'm muting all. I'm sorry, I'm unmuting all for just for the confirmation that you understood. I'm unmuting all. My students,
Yes, sir.
I think it's clear.
Yes, sir. It
Yes,
is
sir.
very easy.
It's
I
clear.
think it's clear, crystal clear. I'm just going slow. That's why your base becomes strong, because after day we'll enter in the complex structure. That's why I'm uh, trying to explain these things. These are the very basic things. Okay. So I think forward
Yes.
bias and reverse bias are clear. Every students.
Yes, sir.
Yes,
Clear.
sir.
Yes, sir.
Okay. 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 Thank you very much. But still, if you have
You're
problem,
welcome.
comment in the chat box. I'm seeing. No problem. Saiful says the net is over. No problem. So please try to give your role in the chat box. Try to give Saiful's role in the
No
chat box.
problem to me. কথা কাটা আসছে নাকি?
Uh-huh. Mustafa, or who is talking about?
নেট প্রবলেম দিচ্ছে, কথা কাটা কাটা আসতেছে স্যার, ক্লিয়ারলি কথা বোঝা যাচ্ছে না।
Amar. Hello. Everyone is listening.
Yes,
Yes,
sir.
sir.
Yes, sir.
Interesting thing is that my internet connection is not creating any problem, because I'm using the broadband. So probably those are not getting the proper audio. Basically their internet is problem. That's why I will upload the video lecture. Okay. So when
Okay, okay.
when you face the problem, you see the video lecture. I will upload the video lecture as soon as the class ends. So I'm
জি
starting.
স্যার।
I'm starting. So this is the source notation. Sometimes the voltage source can be used just like a small circle, very small circle, something like that. Okay, when you will see something like that, that E plus 10 electron volt, 10 volt, and a very small circle, you will understand this is the meaning of that. The plus 10 volt is basically the positive voltage, the positive 10 volt, the small notation. And when you will see this E equals to minus 5 volt, this is small circle, then the negative sign will be upper side. The negative sign will be the upper side, so it will be the negative voltage. So this is just nothing, just a source notation, a representation of voltage source in a different way. Always remember, when you will see the plus positive voltage, the positive side will be the upper side or the close to the node, but when you will see the negative side will be the upper side. Okay, upper side means closer to the point. If we'll check in the next example, then you will understand. Suppose here the positive 20 volt and there is a small circle. So how will be there? So this is the point. So now the positive side will be closer to there, closer to this point, something like that. You see that? Now the positive sign, this positive sign is closer to in this point. Okay, I think you understand. See that? Just the comparison. The positive, so the positive terminal in the upper side or the closer to the point. So in this diode configuration, we need to find out the diode, the current, the voltage drop across diode, the second diode voltage, the second diode voltage, and also the output voltage. See that the V output, here is the V output. It is just like V output is given. Suppose it is positive, that's why we will deal with. So now we will just change this circuit and make it a bigger one, just changing. You see that I'm just explaining the 20 volt in this direction and also the V output in this direction. There is no change, from this here to here. There is no change. You see that there is two diode. The two diode is given, the one voltage source 20 volt and one resistance is given. Interesting thing is that we need to find out the diode, the current, the id. Here the id will we need to find out. We need to find out the voltage vd2, that means here the second diode voltage, and we also need to find out the v output, the voltage across the resistance. I think you have already studied the electrical circuit, so you'll understand very properly. So before solving, we have two diodes in series. You see that this diode in forward bias condition, this diode is reverse bias condition. The first one is forward bias condition, the second one is in the reverse bias condition. Okay, so you see that this will be shorted, but this will be open circuit. This will be open circuit. Let's go to the next. Now you can see that this is short circuit, this is open, this is totally open. As this is the open circuit, so the current will not flow from here to in this resistance, because this is open circuit. How can the current will pass this open space? It cannot pass. So basically the current, you see that as the second diode is the reverse biased, so the current, the id equals to 0. There will be no current, id equals to 0. As this is id equals to 0, the ir will be also 0, because there will be no current in the resistance. As the resistance current is 0, the voltage across the resistance is also 0. So we can see that the voltage across the resistance was the output voltage VO. As the VR is 0, the output voltage is also 0. Hope you understand. Okay, so only one thing is left. Sir, what will be the voltage in this diode? What will be the voltage? You see that no voltage is applied here. No voltage will be in the first diode, though the first diode is silicon diode and it should be 0.7 volt, but we all know that there is no current flowing. Because there is no current flowing, because it is already open circuit from the very beginning. From the very beginning there is no current flowing. That's why the first diode cannot reach the 0.7 volt, cannot reach, because there is no current flow. When the id equals to 0, the vd will be automatically 0, automatically 0. So there will be no current flow. That's why the whole voltage, there is a question coming from one student. I'm just checking. Shafi said, sir, why do you shorted vd1? Yes, interesting question, sir. Why we shorted? Why we shorted? This is forward biased. Interesting, very interesting. The condition is in forward biased, but the second diode is in the reverse biased. You just go to the previous. You see that this positive terminal is going here, so this is positive, this is negative. So the p is in positive, n is the negative. So the first diode is in the forward biased, but the second diode is in the reverse biased. So when the reverse bias, it becomes open circuit. When the forward bias, it becomes closed circuit. Okay, that's why it is shorted. So what I'm trying to say, there is no current, but it is forward biased, but there is no current flowing for this open circuit. That's why the whole 20 volt, the whole 20 volt will be applied in this open circuit terminal. That's why it is said that all the voltage 20 electron volt will be applied on the second diode as open circuit voltage. So vd2 will be equals to 20 volts. So don't get confused, don't get confused. sir, the VD1 will be the 0.7 volt. No, because there is no current flowing. So there is no current flowing from the very beginning. That's why the VD1 equals to 0, and the whole voltage will be applied in the open circuit voltage as in the second terminal in the second diode VD2. Amit said, sir, since we have voltage source and one diode, why don't we calculate the ID? Yeah, interesting thing is that you said that, sir, we have voltage source and we have also first diode which is in forward biased. Okay, but still why we do not calculate the ID? You see that this ID, this current ID will start to flow, but here after going this term in the second diode, it already reverse biased, my student, it's already reversed biased, so it will cannot pass this terminal, cannot pass this terminal, it cannot pass this terminal, so it cannot go back to the voltage source again, so it cannot, you know, it cannot complete the cycle. the the the, the current starts flowing, but as soon as it goes to the second diode is reverse bias. That's why it cannot complete the current. It cannot complete the current. For that, it cannot go back to the voltage source again. That's why we cannot calculate, because the whole circuit is open circuit, and in the open circuit there is no current flow. Always remember, when the circuit is open, there will be no current flow. There will be no current flow. When the circuit will be shorted, total circuit will be shorted, there will be zero voltage drop. Zero voltage drop. So that's why the current is zero, because this is the open circuit for the second diode, as it is the reversed bias condition. That's why the ID equals to 0. So that's why the VD1 is also equals to 0. So the IR is also 0. The current across the resistance is also 0, because this current is not passing from here to there. So all the voltage will be applied as the open circuit terminal voltage. So the VD2 will be the 20 volt. Hope you understand. See one more configuration. Just for better understanding. Determine the current, the V1, the V2, and the V output for the series configuration. You see that this is the notation, one notation. You check. This is one more notation. Minus electron volt. So the positive side will be the closer, the negative side will be the closer. Okay. So we are just transforming this circuit using that. So now you can understand. As this is the positive 10 volt, we just replace using this plus 10 volt, and you see that this is the minus, so that's why the minus sign is the upper side and the positive side is the lower side. Hope you understand the configuration. So this circuit and this circuit, there is no change, just as representation of the voltage source. So we need to find out the V1 is the voltage across the first resistance, the V2 is the voltage across the second resistance. We also need to find out the current I, and finally we need to find out the output voltage VO. Okay, so you can see this diode is in forward biased. This diode is in forward biased, so the circuit is closed. At first we need to see whether the circuit is open or closed. If it is forward biased, the circuit is open. The circuit is closed. If it is reverse biased, the circuit is open. Okay, so from this configuration, at first what we'll do, we will first apply the KVL in this first loop. In the first loop we will apply the KVL. When we will apply the KVL, we're taking the second sign, so the plus 10 volt, then the second sign minus VI, then the second sign minus VD, the diode voltage, then the second sign minus V2, and last the second sign plus 5 volt. So we are applied just the KVL. I think you know KVL properly. You know, the summation of all voltage in a loop is equals to 0. The summation of all voltage equals to 0 in a loop. This is known as mesh analysis. This is known as mesh analysis. You have studied electrical circuit 1, electrical circuit 2. It will be very easy concept for all of you. It's very easy concept. Just taking the sign, either first sign or the second sign. We are taking the second sign. That's why the plus 10 volt, the plus is the negative second sign for like this voltage source. The minus V1, the minus VD, the minus V2, the plus 5 volt. So they applying the KVL. So what will be the VD? So we just replace the V1 as IR1 and V2 equals to IR2, because this is the series current I flowing. Okay, so we just replaced V1 equals to IR1 and V2 equals to IR2, and we sum 10 and plus 5 equals to 15 volt. This is just Ohm's law. V1 equals to IR, V equals to IR, we all know that. This is the Ohm's law. Okay, so now we just take all the I one side and all the value other side. So we take common I. So then R1 plus R2, we take this R1 plus R2 on the other side. Finally, we get the equation for I. 15 minus VD R1 plus R2. 15 minus VD R1 plus R2. VD is the diode voltage. As it is silicon, we know that it is the 0.7 volt. So finally, we replaced 15 minus 0.7 volt, and this 4.7 and 2.2 is the resistance value given in the circuit. So when we'll divide, we'll get the current 2.07 milliampere. This is the current. This is the current. So to find out, we need to find out, you see, we need to find out the I, the V1, the V2, and the V output. We already find out the current value I. So the V1 and V2 is just like, we all know that V1 equals to IR1 and V2 equals to IR2. We have find out the value of I, 2.07. We just multiplied these two value, we get the two voltage value very easily. Just the multiplication, nothing else. And finally, to find out output voltage, the output voltage, we will apply the KVL in this second loop. In this second loop, we will apply the KVL. So at that time, it will be, if we take second sign, or suppose take first sign, then it will be plus 5 volt. Then it will be plus 5 volt minus V2 and plus V0. Plus 5 volt minus V2 plus V0, something like that. There's the KVL. Plus V2 minus V0 plus V0. Plus V2 plus 5 volt minus V2 plus V0. We need to find out V0. So that's why V0 in the one side, that is other side. We replace the value V2 4.55. That is already we have find out here V2 4.55. So finally we put the value, we get the value V0 equals to, or V output equals to minus 0.45 volt. The minus sign is basically indicates that V0 has the polarity opposite that is shown. So basically here we have given the sign plus and minus. So this will be plus, this will be minus. The opposite, the V0 value is basically the opposite value, the minus 0.45 voltage. Hope you understand the whole equation. So I'm just taking for 1 minute break. Just give me 1 minute. I'm just going for drinking water. Give me 1 minute break. I'm also giving one minute break. Just Just see and see this structure. Okay. Okay, I'm unmuting all. Dear students, is there any problem?
No, sir.
Okay, okay. That's very nice of you. Uh, should we start again?
Yes, sir.
Okay, we're starting again. Today we are just seeing that how the diode works in the circuit. Okay, so very important things. From this circuit you can see there are two diodes in the parallel. The previous example, whatever we have seen, those are in the series. Now the diode is in the parallel. You see that the two diodes in the parallel. We all know that what is parallel. Parallel means two branches connected together and the two terminals are same. You see that for these two diode, the two terminal are at the same point. The two terminal are at the same point. So the question is to determine the VO or the V output, that is this one, the V output, the I1, that is the current here, this I1, the ID1, the ID2. ID1, this current across this first diode, ID1, the current across the second diode is ID2. So we need to find out, okay, we need to find out that. So we all know that these two are silicon diode, and if you can see all these two diodes are in the forward biased condition, forward biased, plus in the P, minus in the N. These two are in the forward bias. Please try to understand, try to practice more and more that how when it is forward bias, when it is reverse bias after this class. Because if you cannot find out what is forward bias, what is reverse bias, it will be very tough for you. So these two are forward bias because plus in the P, negative in the N. Okay. So these two are forward bias. So we all know that this is the silicon diode. So the barrier potential will be the 0.7 volt. So the voltage across the two diodes will be the same, the 0.7 volt. Both are silicon diode. So that's why the voltage will be 0.7 volt. Okay. So already, if this is VD1, this is a 0.7 volt, this is 0.7 volt. Suppose see that the V output is also parallel with this diode, and we all know that in the parallel branch the voltage remains same. In the series circuit the series current are same, and in the parallel circuit the voltage across the two parallel branch, the V output is basically the voltage across this diode or this diode. So the diode voltage are equals to the output voltage. So that's why the V output equals to VD1 or VD2 equals to 0.7 volt. Very interesting. Next, we need to find out the current I1. So how we will find out the current I1? This current I1 is basically the IR, the current across the resistance, IR. Okay. So to find out, definitely VR divided by R will get. Okay. So that's why the I1 is equals to VR divided by R. So what is VR? The VR is total voltage minus the diode voltage. because the total voltage is applied here 10 volt. From this 10 volt, the 0.7 volt is applied here. So the rest of the voltage will be applied in this resistance. That is KVL. You all know that. This is input voltage. Input voltage will be the summation of drop voltage. So the 0.7 voltage is here. So the rest of the 9.3 voltage will be across the resistance. So the current will be the voltage divided by the resistance 0.33 kilo ohm. You see that? So the I1 equals to the VR by R E minus VD, basically 10 minus 0.7 volt. So finally we get the current I1. Current the I1. So next, find out the current of ID1 and ID2. We all know that this is the node and the KCL. The entering current equals to outgoing current. So the current entering in this here and exiting from in this diode and also in this diode. So the entering current will be the summation of the exiting current, exit current. Okay, ID1 and ID2. You see that these two diodes are same voltage drop, same characteristics. So the same amount of current will flow within these two diodes. So the I1 will be divided equally. The I1 will come from here and will be divided equally in this diode and also in this diode. So that's why you can see both the diodes are same and the same voltage. That's why ID1 equals to ID2 equals to I1 by 2 will be divided equally. Okay, so the 28.8 we divide by 2, we get 14.9 milliampere. That is the two diode current. So why these two diode current are same? Because the both diode has the same voltage, and both the diode has the same configuration. That's why the current I1, when it will come in this node, we all know that in the node, that is KCL, the entering current equals to the exit current. So that's why the current will be divided equally in the both diode 1 and the both diode 2. So I hope you understand this example. It's a very easy one, but looks complex in the structure. So this is the last one. Probably this is the last one example we'll discuss today. You see the configuration. There are two diodes. One diode is here, one diode is here, and both the diodes are in forward biased condition. Both the diodes are in forward biased condition. So we need to find out the current I1, I2, and ID2. ID2. What is the I1? What is I1? I1 is the current across the VR1. VR1, the current across VR1. So what is ID2? The ID2 is the current across R2. Okay, this current is flowing here. The current I2. So what is ID2? The ID2 is the current across this diode, the diode number 2, the second diode. So basically this is the node. This is the node. So the I2 current entering in this node will be the equals to the summation of the two current ID2 plus I1. Remember, this is the entering current I2 and the exit current ID2 and I1. So the summation of current of ID1 plus I1 equals to I2. So we need to find out these three currents. So to find out these three current, so at first find out the current I1. How? The current I1 will be the voltage divided by the resistance. So VR1 divided by the resistance 3.3 kilo ohm. You see that this is the diode, this branch, and this diode voltage is 0.7 volt. This branch and this resistance are parallel. Both has same two terminal. These two are parallel. So the voltage will be VR1 will be same as the VD2, 0.7 volt. That's why if we find out the I1, here, which will be something like that. As the VD1, VD2 equals to VR1 0.7 volt. So the I1 will be the 0.7 by 3.3 kilo ohm, which will be 0.212 milliampere. That is the I1 current. Now we will apply the KVL in this structure. Apply the KVL. If we apply the KVL, it will be, if we take the second sign, then the plus 20 electron plus 20 volt minus 0.7 volt minus 0.7 volt. Okay. And finally minus VR2. If we apply the KVL, you see that. So minus VR2 plus 20 volt minus VD1 minus VD2. Applying the KVL in this first loop. Again see. So minus VR2, because this current will flows in this way, the clockwise the current will flow. Okay. So minus VR2, we're taking the second sign. Then plus 20 volt, then minus VD1, that is 0.7 volt, then minus VD2, that is 0.7 volt. So if we apply this and put all the value, we will get the VR2, which will be 18.6 volt. So we get the voltage across R2. We know the resistance. We apply Ohm's law. We get the current 3.32 milliampere. So you see that we get the current I2, we get the current I1, and this is a node. This is a node. We know that the entering current equals to the exit current. So I2 will be the equals to ID1, sorry, ID2 plus I2 for applying KCL. So at node 1, ID2 plus I1 equals to I2. We need to find out ID2. So put the value I1 here and put the value. Finally, we get the value of ID2 equals to 3.11 milliampere. So it's same as electrical circuit, the KVL, the KCL. So we'll apply those things, and just remember one thing, that for the diode is forward biased or reverse biased. If it is forward biased, the voltage will be 0.7 volt for silicon. So that's it for today. I hope that it's a very long class, so I think you understand properly. I'm muting all my students and also stopping the share. I'm unmuting all my students and stopping the share. I hope and starting the video also. Dear my students, hopefully you understand properly.
Yes, sir.
Okay, nice.
Yes, sir.
When I will also give the slide